Hello, everyone, and welcome back. I hope you had a nice couple weeks off, and I hope you're doing well now. I hope you're feeling well. We are going to pick back up with the law of sines and the law of cosines, which is what we were covering before we were out. I have put a blank copy of these notes out in Schoology, so if you would like to pause the video now, go grab a copy of those. I think it'll help you to kind of fill in as you go. You will definitely learn better if you're listening, seeing, and using your other senses by writing everything down, especially in this e-learning environment. I'm going to go through this. I will only do 2 of the 4 examples just to save time and make the video a little bit shorter, but I will post notes that do show all 4 problems solved. I'll challenge you to try those other 2 examples on your own and then go check the answers before beginning the homework. And just so I don't forget, the homework will just be the back half of that law of sines worksheet. The other half, remember, was about law of cosines. So just take out that worksheet that you started before we left and then flip it over and just do the back half of that worksheet. And then tomorrow I'll have a review assignment. All right, so getting back to it. Before we started with the law of sines and law of cosines, you were dealing with a lot of different methods to solve angles or sides in a right triangle. You had the Pythagorean theorem, you had SOHCAHTOA. Well, in this section, we don't get right triangles. We're getting all those triangles that are acute, obtuse triangles, but are not right triangles, so we can't use those tools. Well, we first looked at the law of sines, and we found that if you take the sine of an angle, divide it by its side, the proportion that's formed is going to be the same as the proportion of another angle compared to its side, which will be the same as the proportion between the last angle in its side. So the law of sines will help us find missing angles or missing sides in acute or obtuse triangles. Well, the one issue that we have with the law of sines is that we always need a matched pair, meaning I would need angle A and side A so that I could fill in completely one of these, and then if I had only, say, side B, I could fill it in and solve for angle B. If I only had angle C, I could fill that in and solve for side C. But I always need at least one matched pair, be it the B's, the A's, or the C's. Well, if we don't have a matched pair, that's when we're going to go with the law of cosines, where we need a bit of information, but we don't need a matched pair. In that last tricky work that I had you do on Friday, and if you didn't get all the way through it, no problem. But if you did work your way all the way through it, you would have gotten these 3 equations. And they all look extremely similar. And really, they all are about the same. What you're looking for as to which equation you want to use is what side or what angle are you looking for. If you need side A or angle A, you're going to use that top equation. If you need side B or angle B, you'll use the middle equation. Or if you need side C or angle C, you'll use that bottom equation. So basically, whatever you need, be it an angle or a side, you pick the equation that has your side on the outside or your angle on the outside. And all this stuff on the inside is other information that you should have contained within the givens of the problem. So the stuff on the outside is what you're looking for. The stuff on the inside you should have. Okay, well, I'm going to do 2 of the 4 examples, as I said. And I'm going to start actually at the bottom with example number 4. Okay, so in example number 4, I am told I've got a triangle ABC. Let's just sketch out a triangle here. We'll say ABC. All right, so side C is 27 degrees. Side A is 5. Side B is 9. Okay, well, I have side angle side. I know that's one of those good ones, so I'm fine. I don't have to worry about multiple triangles. And I've been asked to find C, side C. So this is what I want. Okay, well, like we just talked about, I'm going to grab the law of cosines up above, with c on the outside because that's what I want. So c squared is equal to a squared plus b squared, looks very much like Pythagorean's theorem here, minus 2a times b. Notice those are the things that we have over in the middle of the equation as well. And then we're going to bookend the other side with our other c thing, right? So on either end of our equation, we have side c and angle c. And we know that's the equation we want because we're looking for something related to c. All right, well, I'm just going to plug and chug these numbers here, right? So I'm looking for c squared. I don't know it. I'm going to plug in for a. I'm going to plug in for b. Same here. And cosine of 27 degrees. And now I'm just going to do some calculator work. And you should be able to see that on the right side of my screen. Okay, when I get all that in, and you could have done it bits and pieces, but I just entered it all in, you end up with 25 point, I'll round to the 100th, 81. All right, well, since this is a c squared and I want what is c, I better take the square root of both sides of my equation. And I get c is equal to, I'll round this to the 10th, 5.1. So that's a very straightforward general problem that you'd be using here. The key is, what are you looking for? I'm looking for c. Grab the equation that has c all the way on the left and c all the way on the right. Plug in and solve the equation. All right, example 3 I'm going to have you do on your own. But note, this one will be solving for an angle. So if we look down here, you'll be missing this side. You'll have the actual side over there. So you will eventually need to use an inverse cosine to get your angle. All right, now I'm going to jump back up to example 1. I'm going to leave 2 for you because it's very similar to 1. This would be a slightly more difficult example because it's not just asking for one particular angle, it's asking for you to find all the angles, right? Because it says solve the triangle. Give me everything that's involved in this triangle. Well, I don't have any matching pairs, so I know I must be using the law of cosines. I've got a side, I've got a side, I've got a side. Okay. Well, I'm just going to pick, let's find C. It really wouldn't matter which one you were trying to find right now. So I'm just going to go ahead and start with angle C. So I'm going to use the one with C on the left and cosine of C all the way on the right. And in the middle, a squared plus b squared minus 2 times a times b times the cosine of C. All right, time to plug those numbers back in. All right. divide both sides by 15. And this calculator gives me this random fraction instead of a decimal, but that's fine. I'm going to have to do my inverse cosine to both sides, which will cancel those, and I will get angle C is equal to, and I can just use that right here in my calculator. 73 divided by 80, 24.1 degrees. Okay, so now I have an angle, 24.1 degrees. All right, so now that I have that angle, I have one of those matching pairs that I'm looking for. I have both angle C and side C. Now I can go back to the law of sines, because the law of cosines is just a lot more calculations. And I will use the law of sines to find both angle B and angle A. So let's set this up. So the sine of angle C, 24.1 degrees, over side C, and I'll set it up twice because I'm going to use it to find both A and B, is equal to the sine of angle A over 3, and is also equal to the sine of angle B over 2.5, right? All right, now I'm just going to, again, plug this into the calculator. We've done a few of these. We're going to cross multiply. So I get 3 times the sine of 24.1, 1.25 times the sine of A, or down here I get 2.5 times the sine of 24.1 is equal to 1.25 times the sine of B. All right. 3. And I know I'm going to divide that by 1.25. So I get the sine of A is equal to 0.97999 is what I'm going to do with that. And here, the sine of B, 2.5 times 0.81666. All right, I'm going to use my inverse sine then to get to my final angle. Okay, so angle A is equal to 78.5 degrees, and angle B is equal to 54.8 degrees. Okay, so now I can go back. I can fill in 78.5, and I can fill in 54.8. Now, there's some of you out there who are wondering, well, why didn't he just use the triangle sum theorem to figure out what angle B is? Once he had A, all he needed to do was figure out 180 minus 24.1 minus 78.5. Well, here's the tricky part, and here's why I'm going to tell you, use the law of sines to find the rest of those angles. Don't try to jump ahead with the triangle sum theorem. At the end, once we've found all of these angles, we want to make sure that these add up to 180 degrees. So over here on the right, I'm going to give it a try. 54.8 plus 78.5 plus 24.1. Aha. When I figured that all out, I only got to 157.4 degrees for the triangle. I know that's a problem because the triangle should have 180. Here's where the issue lies. I've told you a lot of times don't trust drawings, right? Don't trust the drawing because the drawing may be lying to you. But in this case, it does look like we have an obtuse triangle. It looks like angle A should be obtuse, but we got an acute measurement for it. We haven't gotten there yet. We will get there. You will understand this once we get a little bit further ahead in some of the sine and cosine work that we're going to do. But the sine of 78.5 degrees is also equal to the sine of an obtuse angle. Our calculators, though, default to the smallest angle. They're going to default to that acute angle. So when we did the inverse sine there, we got the smallest possible angle that would have that sine. How we find the other angle, and here's what you do. You would look, as soon as you see that you have this problem, the first thing I want you to do is go back up and look at your three side lengths. 3, 2.5, and 1.25. And where you are missing degrees is going to be this angle that looks out on that biggest side. So in this, since the biggest side is 3, I know that I'm missing degrees in angle A. And how I find the rest of those degrees is I just take 180 minus what I got for angle A. And what that will give me is the true measurement of angle A. So angle A should not, in fact, be 78.5. It should be 101.5 degrees. Okay, so I'm going to cross it out. Angle A should be 101.5. Now if I add these up in total, 101.5 plus 54.8 plus 24.1, I get this triangle 180.4. If you're close like that, if you're, say, between 179 and 181 degrees, don't worry. That's just a rounding issue that you had by calculating the three angles. Okay, now I'm going to encourage you to go do number 2, figure out side B, figure out angle A, figure out angle C. When you get to the end, add up the 3 angles you found using the law of sines. Make sure they're close to 180. Okay, a reminder, just do the back side of the law of cosine or law of sine sheet. It should say law of cosines. Work through those problems. I'll get an answer key posted for that so you can take a look at the answers. And tomorrow I'll have posted a review video and we'll be quizzing on Wednesday on this. I hope you're having a